In this video, I'll be going through an A-level pure mathematics practice exam. These questions are designed to help you prepare for any assessments you might have coming up. All of the questions are based on past Edexcel exam questions, but if you're with a different exam board, this will still be useful revision. I suggest you give the questions a go before you watch the solutions, so you can either pause the video on each question or download the question paper, which I'll link in the description. Question 1, part A says, find the first four terms in ascending powers of x of the binomial expansion of the square root of 1 plus 4x, giving each coefficient in its simplest form. So for part 1, we need the generalized binomial theorem, which looks like this. It's 1 plus ax to the power n, where n can be a fraction or a negative number. And this equals 1 plus n times ax plus n times n take 1 over 2 factorial ax squared plus n times n take 1 times n take 2 over 3 factorial ax cubed, and so on. This is an infinite expansion. And this formula is in your formula booklet, so you don't have to memorize it. Here it is. It's 1 plus x to the power n. Now in this formula, they do not have a coefficient of x. All you need to do to modify that is plug in the coefficient in front of x in each term. So here we have just x squared. If there's a coefficient of x, make sure you square that as well with x. Okay, so that's what I've written here, ax squared. Okay, so let's apply it to this expression. We can write this as 1 plus 4x to the power of a half. That's another way of writing the square root. So applying this theorem, we will have 1 plus n is a half. A is 4 times x plus a half times a half take 1, that's negative a half. And then 1 over 2 factorial is also a half. And this is multiplied by 4x squared. And then we have a half times negative half times a half take 2, which is negative 3 on 2. And then 1 on 3 factorial is 1 on 6. And this is multiplied by 4x cubed. And it says the first four terms, these are our first four terms of this expansion. Okay, let's go ahead and simplify. So the 1 stays as is, 4 on 2, we can write as 2x. The second term is going to be negative 1/8 times 16, 4 squared is 16. So 16 on 8 is 2, so this will end up to be negative 2x squared. For the third term, I'm going to cancel that 3 with the 6. So in the denominator, I'm going to end up with 2 times 2 times 2 times 2, and the negatives will become positive. So this would be positive 1 on 16, and 4 cubed is 64. So to evaluate this term, it'll be 64 divided by 16, which is 4. So this would be positive 4 after you simplify everything, x cubed. Okay, and I always write the plus ... just to indicate that this expansion continues, but we don't care about any more terms because we haven't been asked to evaluate them. Okay, so that is what your expansion should look like there. Part B says explain why x equals 26 on 4 should not be used in expansion to find an approximation for root 27. So for part B, you need to realize or remember that this expansion is only valid when this term, this ax term, is less than 1, or the absolute value of ax is less than 1. You can say something like, this expansion is only valid when the absolute value of ax is less than 1. So if we have 26 on 4, we would have 4 times 26 on 4, which equals 26, which is clearly, the absolute value of 26 is clearly not less than 1. So you can just say, 26 is greater than 1, so this is not a valid, value for x. So x equals 26 on 4 should not be used, and this is because, when you do this expansion, if you want to use an approximation, you want the larger powers of x to get smaller. If you think about the next term, that would be x to the power 4. If this term in here is greater than 1, those terms will actually be getting bigger. So you can't ignore them if you're using this for an approximation. So you take small values of ax, and then you can just use a small number of terms for the approximation. Okay, so part C, says, explain how you could use x equals 1 on 50 in the expansion to find an approximation for the square root of 27. There is no need to carry out the calculation. So let's see what happens if we plug 1 on 50 in for x here. So we've got 1 plus 4 on 50. So I've plugged that into 1 plus 4x. And this we could write as 1 plus 2 on 25. And then if we want to combine these numbers, we need to multiply this by 25 on 25. So this would be 25 plus 2 on 25, which we could write as 27 on 25. And we're taking the square root of all that, so I should have written the square root symbol. Okay, so the square root of 27 on 25 we could write as the square root of 27 on 5. So if we plug x equal to 1/50th into this expression, we would get an approximation to the square root of 27 divided by 5. So we would need to multiply this expansion by 5 to get an approximation for root 27. So let's summarize that in a couple sentences. So if we sub in x equal to 1/50th, we need to multiply by 5 to get an approximation for the square root of 27. So there you go, that was question 1 for a total of 7 marks. Question 2 says a herd of cattle is released into a paddock completely covered by grass. The area covered by grass, a meters squared, t hours after the cows are released, is modeled by the equation a equals 10,000 take 12e to the power of 0.05 t, where t is any real number and t is greater than or equal to 0. According to the model, part A says state the area of grass coverage before the cows are introduced to the paddock. So here we want to let t equal 0, plug that into this equation and get the area. So for question 2 part A, just let t equal 0, we will have a equal to 10,000 take 12, right? Because e to the power of 0 is 1, and then we get 9,988 meters squared. Part B says find the time taken in hours to one decimal place for the area covered by grass to fall to 1,000 meters squared. Okay, for this one, we want to let the area equal 1,000. So plug 1,000 in for A, we're going to have 1,000 equal to 10,000 take 12e to the power of 0.05 t. Then subtract 10,000 from the left-hand side. So I'm going to switch the equation around. We'll have negative 12e to the power of 0.05 t equal to negative 9,000. Divide by negative 12. Might as well get our calculators out for that. So 9,000 divided by 12. That will give us 750. So we get e to the power of 0.05 t equal to 750. Then you want to take the natural log to bring that t, down a level if you like, and we'll have 0.05 t equal to the natural log of 750. Then calculate that. So ln of 750 is equal to 6.62, and then we want to divide by 0.05. So 0.05. And we get 132.4. So t is 132.4, and the question said to one decimal place. So we need to use approximation sign, and that was in hours. Okay, that's part B. Part C says Gregory wants to predict the area of grass coverage 6 days after the cows are first introduced. Explain why he should not use this model. So for this, we want 6 days in hours. So 6 days is 6 times 24. I'm feeling lazy, so let's use our calculator. That's 144 hours. Okay, so the reason we did this is to plug that in for t into this equation because t is in hours. So then let's work this out. So we're going to have 10,000 take 12e to the 0.05 times 144, and then we just need to calculate that. So 10,000 take 12 times e, find the e on your calculator wherever that is, 0.05 times 144, and usually it's good practice to put brackets around the exponent just to make sure that the calculator knows all of that is in the exponent. And we get a negative area. So let's write that down, negative 6,073 point whatever. And we don't want a negative area, right? That is showing us that, well, this equation is no longer appropriate after a certain number of days have gone past. So we can summarize that. We can say as the model gives a negative area. So as the model gives a negative area, it is not suitable after 6 days. That's all you really need to say there for part C. And that was question 2 for 6 marks. Question 3 says the sequence u1, u2, u3, and so on is defined by u sub n plus 1 equals 9 over 3 take u sub n, where u sub 1 equals 1.5. Part A says show that this sequence is periodic, stating the period. Okay, so for 3, what you want to do is start off with u sub n equal to 1.5. So we're going to be working out u sub 2, the next term in the sequence. This is equal to 9 over 3 take 1.5. So we've taken that value for u, substituted it into this iterative formula. So then this is 9 over 3 take 1.5 is 1.5. So 9 over 1.5. This is 6, right? 1.5 goes into 9 6 times. Okay, then we can work out u sub 3, plugging 6 in for u sub n. So this is 9 over 3 take 6. This is 9 divided by negative 3, which is negative 3. And then we want to work out the next term. U sub 4 is 9 over 3 take negative 3. In other words, 9 over 6, which is 1.5. So we've got back to that first term, which means we can stop. And how many terms we have? Well, the sequence looks like this. We have 1.5, 6, negative 3, and then we get back to 1.5 again. So we have 3 terms in that sequence. So we say that its period is 3. So for, this is part A, we would say the sequence is periodic with period 3. Part B says, hence find the sum from 1 to 50 of the sequence u sub n. In other words, this is saying find the sum of the first 50 terms of this sequence. Well, how many times would this period repeat over 50 terms? Well, let's just think about what 50 divided by 3 would be. Well, 3 goes into 48 16 times, so this would be 16 remainder 2. So we're going to have 16 lots of each term, and then 2 more terms starting from the first term. So we can say then that the sum from the first term to the 50th term of u sub n is equal to 16 times the sum of these terms. So 16 times 1.5 plus 6 take 3. And then we're going to have the first term again, so 1.5, and then the second term, which was 6. So then we just need to work this out. 1.5 plus 6 take 3, that's 3 plus 1.5, so that's 16 times 4.5 plus 7.5. And why not use a calculator? Because we can. So this is 16 times 4.5 plus 7.5. And you should get 79.5 for that sum. And that was question 3 for 5 marks. Question 4 says h of x equals 5x cubed take 32x squared plus 57x plus 18 over x take 3 all squared. And part A says write h of x in the form ax plus b plus c over x take 3 all squared, where a, b, and c are constants to be found. So for part A, you can use polynomial division, or you can use the remainder theorem. The remainder theorem says if you're dividing by some binomial, such as x take 3, if you plug in 3 into this polynomial in the numerator, that will give you the remainder. So that's what I'm going to do here. If you're not comfortable with the remainder theorem, use polynomial division. It'll work out perfectly fine as well. So plugging in 3 into this polynomial, we'll have 5 times 3 cubed, take 32 times 9 plus 57 times 3 plus 18. And if we calculate that, I get 36. So the remainder here is 36. In other words, that's the c in this expression. Okay, so we can say h of x is equal to ax plus b plus 36 on x take 3 all squared. And for this expression, we can recognize if we subtract 36 from this polynomial, then x take 3 will be a factor. So we can say that ax plus b multiplied by x take 3 all squared is equal to this polynomial, subtract 36. So 18 take 36 is negative 18. All right. So now we can solve for a and b just by inspection. We can see a must be 5 to get 5x cubed. So ax plus b is equal to 5x. And then we have plus b times positive 9 equals negative 18. So b must be negative 2. So therefore we have a, b, and c. We can say h of x is equal to 5x take 2 plus 36 over x take 3 all squared. Now if you're not comfortable with what I did there, yeah, as I said, use polynomial division. It will work out as well. Okay, part B says find the integral of h of x dx. So the integral of h of x dx is going to be the integral of this expression. And we can do that because we can just integrate each term. The integral of 5x, add 1 to the exponent, divide by that exponent. This will be 5 on 2 x squared. Negative 2, we just, introduce the x. And then think of this exponent here as a negative 2. Then add 1 to negative 2, that's negative 1. So we're dividing by negative 1. This will be negative 36 over x take 2 to the power of 1. And we also need to remember to plus that c on. If it's not a definite integral, always remember to add that constant. And that was question 4 for 6 marks. Question 5 says, relative to fixed origin O, the point A has position vector negative 2i plus 2j. The point B has position vector 3i plus pj, where p is a constant. And the point C has position vector qi plus 5j, where q is a constant. Given that the modulus of the vector AB equals square root of 41, find the possible values of p. Okay, so let's think geometrically for a minute. Let's interpret these vectors, on a set of axes. Okay, so negative 2i plus 2j, that's negative 2 in the horizontal direction and positive 2 in the vertical direction, somewhere over here. So let's just represent that point as negative 2, 2. That would be A. And then point B is going to be 3 in the positive horizontal direction, but we don't know the x-coordinate. So let's just write it up here somewhere. It might be also down here as well, but this would be 3p, and that's point B. Okay, now we know the vector AB has a length of the square root of 41. That's what this modulus means. So that vector has a length of square root of 41. And then let's draw a right triangle. So we have the horizontal distance between A and B and the vertical distance. We know the horizontal distance because we know the x-coordinates. This one's negative 2, this one's 3, so the difference is 5. We don't know the vertical distance, that's what we need to find. But we can represent it as the difference between these two coordinates, so p take 2 or 2 take p, either way it will work. So then we're essentially using Pythagoras' theorem to solve this, right? Well, let's say that the 1 leg squared, 5 squared plus p take 2 squared equals the hypotenuse, so square root of 41 squared. And now this is the equation you need to solve for p. So let's firstly expand these brackets out. So we're going to have 25 plus p squared take 4p plus 4 equal to 41. And then we've got 29, 24 plus 4 is 29, take 41, that's 12. So we're going to have p squared take 4p take 12 equals 0. And then we can factorize this. Factors of negative 12 that make negative 4 are negative 6 and positive 2. So then we have our values of p of 6 or negative 2. Okay, so that was part A for 3 marks. Part B says, given that the angle between AC and the unit vector I is pi on 6 radians, find the exact value of Q. Okay, so C was Qi plus 5j. So let's go back to our diagram. So we know that Q is somewhere, 5 units in the positive vertical direction. Let's just draw it up here. But we don't know the x coordinate, so let's just write q5. And the angle between AC and the unit vector I, we can represent that firstly by drawing AC. So this was C. The unit vector I is, just the horizontal, basically. Horizontal line. So that's saying this angle in here is pi on 6. So this angle is pi on 6. Okay, so let's draw another right triangle. This vertical distance we know because we know the y coordinates of the 2 points. A was 2, C is 5, so this vertical distance is 3. That's this distance in here. But we don't know the horizontal distance. So now think about which trigonometric ratio relates the opposite side and the adjacent side to the angle. That's the tan ratio, right? So for part B, I should have written A over here as well. For part B, we're going to say the tan of pi on 6 is equal to 5 over this horizontal distance. Now, how can we represent that? Well, that's the difference between the x coordinates. So we could write that as, I'm talking about this distance here. We could write that as q take -2. In other words, q plus 2. So this is going to be the opposite side, which I should have said is 3. I don't know why I said 5 there. That's 3 over the difference between the x coordinates, which is q plus 2. Now the tangent of pi on 6, you need to know the absolute value of that. I remember it with this right triangle with the two angles 30 and 60, or pi on 6 and pi on 3. And I just remember these numbers, 1, 2, root 3, and then I remember the angles. So the angle opposite 1 must be the smaller angle, that's pi on 6, and the other one is pi on 3. So the way I remember this right triangle is just 1, 2, root 3. Once you remember those numbers, I think it's fairly easy to remember where they go, and then you can remember where the angles go. So the tan of pi on 6 is the opposite over the adjacent, so that's 1 on root 3, and this is equal to 3 on q plus 2. And then let's rearrange in terms of q. So this is going to be q plus 2 equal to 3 root 3, and then q is equal to 3 root 3 take 2. And we're done for part B. And that was question 5 for 6 marks. Question 6, part A says, use the identity cosine of a plus b to show that the cosine of 3 theta is equivalent to cosine cubed theta take 3 sine squared theta cosine theta. Okay, so remember the sum formula for cosine of a plus b. That's cosine of a, cosine of b, subtract sine of a, sine of b. So the way I remember that is if it's cosine, you're going to have two of the same, together if you like. So cosine, cosine, and sine, sine. And it's the opposite for the cosine. So if we have plus in the brackets, it's a negative when you expand it out. And if it's sine, then it's the same sign. So sine of a plus b is sine cosine plus sine cosine. Anyways, to use that identity, we're going to say cosine of 3 theta is cosine of 2 theta plus theta. So plugging 2 theta and theta in for a and b, we're going to have cosine of 2 theta cosine theta take sine 2 theta sine of theta. And then we want to use the identities, the double angle formulas. One of the identities for cosine 2 theta is cosine squared theta take sine squared theta. This is multiplied by cosine theta, and the only identity you need for sine 2 theta is 2 sine theta cosine theta multiplied by sine theta. Okay, so then if we expand these brackets out, we get cosine cubed theta take sine squared theta cosine theta, and over here we have sine theta times sine theta, so that's 2 sine squared theta cosine theta. And then these are like terms, they're both sine squared cosine, so then we can say this is cosine cubed theta take 3 sine squared theta cosine theta, and we are done. Part B says, given that cosine of beta equals the square root of 7, use the answer to part A to show that cosine of 3 beta equals a root 7, where a is a constant to be found. Okay, so here we just want to substitute in the square root of 7 for cosine theta. So let's say cosine of 3 beta equals cosine cubed theta would be root 7 cubed. And then we have sine squared theta we need to change into cosine somehow. So we can say sine squared theta is 1 take cosine squared theta. So there I'm using the fact that sine squared theta plus cosine squared theta equals 1. So sine squared equals 1 take cosine squared. And this is multiplied by cosine theta, cosine beta, which is square root of 7. Okay, and then square root of 7 cubed is 7 root 7. And this is 1 take cosine squared. And I should have used beta there because we've changed the letter. Cosine beta squared is square root of 7 squared, which is 1 take 7. So then this just becomes negative 6. So then we're going to get 7 root 7. Negative 6 times negative 3 is positive 18 root 7. So then this is 18 plus 7, which is 25 root 7. So A is 25, and that was question 6 for 6 marks. Question 7 says, a scientist is modeling the number of people n who have fallen sick with the virus after t days. Scientists suggest that the number of sick people can be modeled by the formula n equals ab to the power of t. The line L shown in the graph illustrates a linear relationship between log of n and t over a period of 10 days. Using the information given on the graph and using the model, find an equation for L for part A. Okay, so here we're just finding the equation of a straight line. Pretty simple stuff. We know the y-intercept is 1.6, so we just need to find the gradient. We use the rise over run to get the gradient, so this is going to be 2.55 take 1.6 over the run, which is 10. This is 0.95 divided by 10, which is 0.095. So then we can say that the equation of L will be y equal to 0.095x plus 1.6. Part B says find the initial number of sick people rounded to 2 significant figures. Remember, this 1.6 is log of n, and n is the number of sick people. So for part B, we can start by saying log base 10 of n is equal to 1.6. Then we would want to solve this for n. So raise everything to the power of 10, and we will have our answer. So log of base 10 of n raised to the power of 10 is just n, and then we get n equal to 10 to the power of 1.6. So put that into your calculator. 10 to the power of 1.6. I get 39.8 and so on. 39.8, and it says round to 2 significant figures, so this would be approximately 40. Part C says find a complete equation for the model giving the value of b to 4 significant figures. Okay, well, if n equals 40 when t equals 0, so let's just say that n equals 40 when t equals 0, that means a equals 40, because we'd have n equal to a b to the power of 0. 40 equals a times b to the power of 0. B to the power of 0 is just 1, so a equals 40. Then we need to find b. We can do that using this point. We need to find n. So for b, we need to say that log of n equals 2.55. Just move this up. So then we can solve this for n using the same method we just used for 1.6. So it'll be 10 to the power of 2.55. That's 354.8 and so on. So now we have this point plugging those numbers in, we have 354.8 equal to 40 times b to the power of 10. So the t value was 10 for that n value. And then we can solve this for b. So divide by 40. Divide that number by 40. We get 8.87. So b to the power of 10 equals 8.87, and so on. Then take the 10th root of that number. So you should know how to do that on your calculator. Mine's a bit annoying. I have to go to this math menu and use this symbol. Hopefully yours is a bit easier. So take the 10th root of that answer, and I get 1.239. So b equals 1.2439, and we needed to round that off to 4 significant figures. So this would be 1.244. Okay, so that's b. So then we can say that the complete equation is n equal to 40 times 1.244 to the power of t. Part D says after 30 days there were found to be 35,000 people who had contracted the virus. Part I says use this information to show that the model is not valid after 30 days. Okay, so for part D, part I, let's let t equal to 30 and see what we get with our model. So n is equal to 40 times, what was b? b was 1.244 to the power of 30. So let's put that into a calculator, see what we get. So 40 times 1.244 to the power of 30. I get 27,968, and so on. So 27,968.64, and so on. Clearly this is a lot less than 35,000. So we just need to say something like this is much less. Therefore the model is not suitable after 30 days. Part 2 says suggest a reason for the model not being valid at this time. So here you need to think of the context. We're talking about a virus. Think of a reason why, what might cause the model to not fit the data. So you could say possibly the virus might be much more contagious than predicted. And try to think of sort of a contextual reason why that would be the case. Okay, so the virus may be more contagious. And that was question 7 for 9 marks. Question 8 gives us a graph, and it says the figure shows a sketch of part of the curve of the equation y equals 5 cosine of x take 45, where x is greater than 0. The point P on the curve is the minimum point with the smallest positive x coordinate. Part A says state the coordinates of P. So here you need to recognize this is a transformation of the cosine function. So if you think about what the graph of the cosine looks like, let's draw a quick sketch. It starts at 90, goes down, it starts at 1, goes down to 90 degrees at 0, and then comes back up, intersects at 270, and the minimum here is at 180 degrees, and it would keep going and have another maximum at 360. So this function cosine of x take 45, that's a transformation to the right, in other words a horizontal translation to the right of 45 degrees. So that's why we're seeing this, sort of starting not quite at the maximum. And so if we shift this graph to the right 45 degrees, the new minimum will be 180 plus 45. So we know the x coordinate is 225, 180 plus 45. And the effect of multiplying this by 5 is a stretch in the vertical direction of 5 units. So rather than having a maximum at 1, we'll now have a maximum and a minimum at 5. So the y coordinate will be -5. It doesn't say to show workings, so I think you could just write down your answer there, but to be safe you might want to write down some workings such as 180 plus 45 or something like that, just to show your reasoning, how you got your answer. Part B says solve for x between 0 and 360 the equation 5 cosine of x take 45 equal to 2 sine of x, giving your answers to 1 decimal place. Okay, so the first thing you want to do here is to use the difference formula for the cosine to expand out those brackets. So this is going to be 5 times the cosine of x, cosine 45, plus sine of x, sine of 45. This is equal to 2 sine of x. Once you do this, start to think about how you might be able to solve this for x. Because we've got cosine and sine, that should give you a clue that you'll probably want to somehow get the tan function. So you want to divide somewhere by cosine of x to get sine x on cosine x and then tan of x. And then you'll be able to solve for x. So the way we can do that is to get all of the sine x terms together. So expand this 5 out. We're going to have 5 cosine of x, cosine of 45. And then take this term over to the right hand side. So this will be subtract 5 sine of x, sine of 45. And then factorize the sine x out of those two terms. So this will be sine of x times 2 take 5 sine of 45. You notice I'm not substituting the absolute value for cosine and sine of 45 yet, mainly because it just makes it a bit messier. So I'm leaving them as is for now. So then we can divide by cosine of x and divide the left hand side by 2 take 5 sine 45. Then we're going to have sine of x on cosine of x equal to 5 cosine 45 divided by 2 take 5 sine 45. And then we have the tan of x equal to this, which has, a value because we can substitute in root 2 on 2 for cosine 45 and sine 45. Root 2 on 2 or 1 on root 2, either way, they're the same thing. And you need to know those absolute values. I'm going to simplify this a little bit just to make it easier to put into my calculator. So this will be 5 root 2 on 2 over 4. Take 5 root 2 on 2. And then I can cancel out those denominators in the numerator and denominator. So then this is 5 root 2 on 4 take 5 root 2. And then I can take the inverse tan of this and get my values for x. So let's put that into a calculator. Inverse tan. Make sure your calculator is in degrees for this question. So this is 5 root 2 divided by 4 take 5 root 2. And I get a value of x of negative 66.52. Negative 66.52 and so on. And you notice that's not in our interval of 0 to 360. So we need to add on that period of the tan function, which is 180. Because the trigonometric functions are periodic, you get the same solutions for x over the period of the function. In this case, it's 180 degrees. So adding 180 to this answer, so add 180, we'll get our first solution of 113.476. 476, and then add 180 again to get our second solution. So 293.476. 293.476. And you can see if you added 180 again, the answer would be outside of our interval, so we don't need to worry about that. And it says to round to 1 decimal place, so this is going to be 113.5 and 293.5 for our two values of x. Okay, part C says, deduce giving reasons for your answer the number of roots of the equation 5 cosine of 2x take 45 equal to 2 sine of 2x for x between 0 and 3600. Okay, so here we need to recognize what this transformation does, doubling that input. So we've gone from x as the input to 2x. The effect this has on the graph, if we do a quick sketch, is to shrink it in the horizontal direction by a scale factor of 1/2. So if we just think about the graph of sine of x for a minute, this would be something like this. So the max here is at 90, the minimum is at 270. If we graph sine of 2x, we shrink it by a scale factor of 1/2. So now the maximum is at 45. It intersects the graph at 90. and we have a minimum at half of 270, what's that, 135, and then it goes up and intersects the x-axis again at 180. So we shrink the graph by a scale factor of a half. So what does that mean for our solutions that we found in part B? Well, if we had two solutions for this equation between 0 and 360, if we shrink both graphs by a scale factor of 1/2, sorry, I think I'm saying that wrong. If we shrink it by a scale factor of 2, then we're going to have 4 solutions between 0 and 360. So with this transformation, we will have 4 solutions for every interval of 360 degrees. So if we're looking at this interval 0 to 3600, that's going to be 10 lots of 4 solutions. So we're going to have 40 solutions. So let's write that down. So 40 solutions for the interval 0 to 3600. And that was question 8 for a total of 8 marks. Question 9 gives us this graph, and it says the figure shows a sketch of the curve of the equation y equals 3 to the power of x squared take x. The finite region R shown shaded is bounded by the curve, the line with equation x equals negative 0.5, and the line with equation x equals 1.5. Part A says use the trapezium rule with 4 strips of equal width to find an estimate for the area of R. Show your working and give your answer to 2 decimal places. So the trapezium rule firstly says that the area that you're looking at is equal to half times the width of the intervals, which we write as h, times the first y value plus 2 times all of the middle y values, so y1 plus y2, etc., all the way up to yn take 1, plus the last y value. And that is in your formula booklet, so you don't have to memorize that. So here they have not given us the y values for the intervals, so we're going to have to calculate those. So we've got the x values. For equal strips of equal width, this is going to be negative 0.5, 0, 0.5, 1, and then the last one is 1.5. And we need to find the y values for each x value using this equation. So firstly, plugging in negative 0.5 into 3 to the power of x squared take x. Might as well just put that into our calculators. Well, I know 0.5 squared is 0.25, so I'm just going to do 3 to the power of 0.25 take, well actually it's going to be plus 0.5, plus 0.5. That gives me 1.816. If I plug 0 in, this is just going to be 1, because it'll be 3 to the power of 0, which is 1 take 0, so 1. Then plugging in 0.5, so 3 to the power of 0.25 take 0.5. This will be 0.816. Plugging in 1, we'd have 3 take 1. I didn't need to put that in the calculator. It's going to be 2. And then the last one is 3 to the power of 1.5 squared. And then we need to subtract 1.5. And that gives me 10.344 and so on. Okay, then we need to take these values and plug them into our trapezium formula. Okay, so the area R will be approximately half of the interval. Well, the h here is a half because we've gone up by intervals of half, so this will be a quarter multiplied by y0, so 1.816 plus 2 times these values added together, so 1 plus 2, let's just write 3, plus 0.816, and then plus the final y value, so 10.344. Okay, so then let's put that into our calculators. So 0.25 times 1.816. I should probably include a few more decimal places just to be accurate. So that gives me 4.948, which we need to round to 2 decimal places. So this is approximately 4.95. Okay, that was part A. Part B says a copy of the figure is drawn below. Explain with the aid of the diagram whether your answer is an underestimate or overestimate of the true value of R. So here they have given us an extra figure I've copied that down here because I can't draw on this one. So you want to draw in the trapeziums that you just used to calculate that area. So firstly, draw your intervals. So 0.5 would be probably about there. 1 would be about there somewhere. Okay, so then join these up. And we can see just from doing that we're clearly going to get an overestimate because we've also added these areas that were not in the actual area R. So for part B, well, this was part B, we can say that it's an overestimate. So it's an overestimate as the trapezia are larger than the true area. Part C says, using your answer to part A and showing your working, estimate the value of the integral of negative 0.5 to 1.5 of 3 to the power of x squared plus 1 plus 3x dx. For this question, we need to use a little bit of tricky algebra. So firstly, let's write down that integral. So 3x squared plus 1 plus 3x dx. Firstly, recognize that if we have 3 to the power of x squared plus 1, we can write that as 3 to the power of x squared multiplied by 3. Okay, so that when you're adding the exponents, it's the same as, multiplying numbers with the same base. Then this plus 3x, we're going to write as negative 3x plus 6. This is quite a difficult detail to see. And the reason is, if we factorize 3 out of this expression, we'll have the integral of, this integral, and factorize 3 out of each term, we'll have 3 to the power of x squared take x plus 2x. And here we have our original graph, 3x squared take x, and we just have that plus 2x on the end. We can bring that constant out the front of the integral. So it's 3 times this integral. And, we have an approximation for this part already. So 3x squared take x. And we just need to worry about the 2x. And actually, we can separate them out, right? The integral of all of this is the same as the integral of 3x squared take x plus the integral of 2x dx. Okay, so the reason we wrote it as negative 3x plus x is so we can separate it out because we have an approximation for this area already. We just need to worry about this one. So we're going to substitute in the value we got from part A into here. So that was 4.95. So this is equal to 3 times 4.95. And here I should use approximation signs because this is no longer an exact value. And then we need to worry about this integral. So this is the integral of 2x is x squared, right? You add 1 to the exponent, divide by that exponent. 2 divided by 2 is 1. So this is x squared from negative 0.5 to 1.5. And this was also multiplied by 3, by the way. So then we're going to get 3 times 4.95 plus 3 times 1.5 squared take 0.5 squared. Okay, so, the upper limit take the lower limit. And then we just need to plug that into a calculator. So we've got 3 times 4.95 plus 3 times 1.5 squared take 0.25. And I get 20.85 as an estimate for that value. And that was question 9 for 8 marks. Question 10 says, sketch the graph with equation y equals the absolute value of 3x take 15 plus 3, stating the coordinates of the vertex and any points where the graph crosses the coordinate axes. Okay, 10 part A. Draw your set of axes. And because it's an absolute value graph, we don't need any negative y values. So the first thing we can recognize is that the minimum value of this graph will be y equals 3, right? Because this can't be anything less than 0. So the minimum will be at y equals 3. We can say the minimum when y equals 3. And then we can find the x value related to that. So we'd have 3x take 15 plus 3 equals 3. So the absolute value of 3x take 15 equals 0. And then we can get rid of the absolute value symbols, because whether it's positive or negative doesn't matter, because it's equal to 0. So then we have 3x equal to 15, so x equals 5. So that's the minimum at x equals 5, y equals 3. So, roughly there somewhere. Then we can find the y-intercept. So when x equals 0, we will have y equal to the absolute value of 15 plus 3. So that's 15 plus 3, which is 18. So we're going to have a y-intercept at 18. So somewhere up here. So we can draw in our first side of our graph. And then the other side is just a reflection of that. Okay, so it doesn't need to be exact. It's just a sketch. So there we have our sketch, and just make sure you label this y-intercept at 0, 18, and then we're done. Okay, part B says solve the equation 3x plus 1 equals the absolute value of 3x take 15 plus 3. For part B, we could firstly draw in this straight line 3x plus 1. So I'd have a y-intercept at 1 and a slope of 3, or a gradient of 3, which would be the same as this graph. So just make sure it looks parallel. Okay, something like that. That would be y equals 3x plus 1. And then we can see there'd only be one solution. Because these slopes or gradients are parallel, it's not going to intersect the graph again. So we're only going to have one solution where the x and y coordinates are both positive, and the x coordinate will be less than 5. So that means that 3x take 15 will be a negative. Okay, so if we write this equation down, to solve this algebraically, you want to consider the positive and negative values of this expression, but because we know now that this must be negative in here because x is less than 5, we can just consider the negative value of this expression. So then we can say 3x plus, well, let's get rid of that plus 1. So subtract that 1. This is equal to negative 3x take 15 plus 2. Then expand that negative to both terms. This will be 3x plus 3x, so 6x equal to positive 15 plus 2, so 17. And then we get x equal to 17 on 6. And that will be our x solution. Well, we didn't need the coordinates, we just needed the value of x. So there we go. That was part B. Part C says the straight line L has equation y equals kx plus 1, where k is a constant. Given that L does not meet or intersect the graph with equation y equals the absolute value of 3x take 15 plus 3, find the range of possible values of k. So let's go to our graph and sort of interpret what we're saying here. We've got a straight line kx plus 1. So again, it intersects the graph at 1. And if it does not intersect with this graph, firstly, it might be this way, right? And in order not to intersect this graph, it must have a gradient greater than negative 3. Okay, because the gradient of this part of this graph is negative 3. So let me just write a note. The gradient of this line is negative 3. So the gradient of line L must be greater than negative 3 or equal to. So it could be negative 3 or it could be greater than that. And it could be anywhere in here as long as it's less than this line over here. So let me just do that in blue as well. So we could have that line going here, and it needs to be just less than intersecting with this point. So it could be anywhere in here, that gradient. Okay. So how can we represent that? Well, firstly, we want the gradient of this line. We've can find that because we have this minimum point and the y-intercept. So let's find the gradient between those 2 points. So the point 0, 1 and 5, 3. So for C, let's say the gradient between 0, 1 and 5, 3 equals the rise over the run. The rise is 2, the run is 5. So the gradient needs to be less than 2 and 5 and greater than or equal to -3. So that's our range of values for K. So greater than or equal to 3, -3, and less than 2 and 5. Again, that would be the line with a gradient anywhere in here. As long as it's not in this part, it would not intersect with that graph. Okay, so that's the answer to part C, and that was question 10 for 8 marks. Question 11 says the function f is defined by f of x equal to 3 plus 5x on x, where x is greater than 0. Part A says find the value of a such that f inverse a equals 5 on 3. This is pretty straightforward if you just interpret what the inverse function tells you. So if we know that f of x equals 3 plus 5x on x, and f inverse of a equals 5 on 3, well, remember that the output of the inverse function is the input of the original function. So let me just write that down. So this 5 on 3 is what we would substitute in for x into f of x. And the input of the inverse function is the output of the original function. So I'll write that as well. So a, the input of this function, will be f of x from our original function. So to find a, all we have to do is substitute 5 on 3 for x into f of x. So we just need to find f of 5 on 3. So this will be 3 plus 5 times 5 on 3 over 5 on 3. And then just simplify this. So this will be 3 plus 25 on 3 on 5 on 3. Then this would be 9 plus 25 all over 3 divided by 5 on 3. Then you can cancel the denominators and just evaluate this as 25 plus 9, that's 34 on 5, and we're done. So A is 34 on 5. Part B says explain why there are no values of x for which f of x is less than 5 on 2. So for part B, you can interpret this function f of x. We can write it slightly differently as 3 on x plus 5, right? So if we separate that numerator into two terms, be 3 on x plus 5. And then think about the graph of the reciprocal function. This is something you learn about when you do graph sketching. You sketch this graph quite a lot. So the graph of 1 on x, looks something like this, really roughly. And it also has a part over here. But we don't have to worry about that because they tell us x is greater than 0. So we don't have to worry about this bit over here. Now, the graph of 1 on x has an asymptote of y equals 0. But if we add 5 to that, we can ignore that 3 for a minute. If we add 5 to that, we're going to be shifting this graph up 5 units. So the asymptote will shift from y equals 0 to y equals 5. Okay, so we'll have a new graph up here somewhere. And then just from looking at that graph, you can see there's not going to be any y values less than 5, no matter what x input you put into that function. And also you can just interpret this algebraically. You can see clearly whatever x input you put in, because x is greater than 0, this is always going to be 5 plus something, right? So yeah, you can interpret the graph or just think about this equation. It's always more than 5. So we can say something like, as x is greater than 0, f of x will always be greater than 5. So there will be no values for x for which f of x is less than 5 on 2. Part C says show that f is a decreasing function Usually when you see this word decreasing or increasing, you want to think derivative. So we want to take the derivative of f of x, f dash x. Well, this is really just the derivative of 3 on x, or 3x to the power of negative 1. So take 1 from the exponent, negative 1 take 1 is negative 2, bring that down the front, that would be negative 6, x to the power of negative 2, or negative 6 on x squared. And this tells you for any x values, you're going to get a negative derivative. That's what a decreasing function is. In other words, as you increase the values of x, the values of f of x are getting less. And the derivative being negative for all values of x is another way to show that. So we can say that f dash x will be negative for all values of x. Therefore, f of x is a decreasing function. Okay, so that was part 11, or question 11, for 6 marks. Question 12 says, using algebraic integration and making your method clear, show that the integral of 2x plus 8 over x plus 5 from negative 1 to 3 equals a log b, where a and b are constants to be found. So firstly, I'm just going to have a look at this expression, 2x plus 8 over x plus 5. Now, to make this easier to integrate, we can mess with it algebraically a little bit. And I'm going to write this x term slightly differently. So I'm going to write it as 2 times x plus 5 take 5 plus 8 over x plus 5. This is sort of an algebraic trick that's useful when trying to simplify integrals. So if you haven't seen that before, then here you go, you're learning it now. This works because I've added 5 and subtracted 5, essentially adding 0, so it's still the same x term. But I can expand these brackets out to get 2 times x plus 5 take 10 plus 8 over x plus 5. And then we can separate the numerator into 2 times x plus 5 over x plus 5. And then negative 10 plus 8 is negative 2 over x plus 5. And then we can cancel these terms. So we just get 2 take 2 on x plus 5. And this expression is much easier to integrate than this one. So now we can say that the integral from negative 1 to 3 of 2x plus 8 over x plus 5 is equal to the integral of 2 take 2 on x plus 5 dx. I should have written there. And we can integrate both of these terms. So the integral of 2 is just 2x. And the integral of negative 2 on x plus 5 is negative 2 log x plus 5. And this is from negative 1 to 3. So then substitute in 3. So this will be 6 take 2 log of 8. Subtract negative 2 take 2 log of negative 1 plus 5 is 4. Okay, then we have 6 plus 2 is 8. Negative 2 log 8 we're going to need to write as 2 log of 2 cubed. And I've dealt with that positive 2. Then this is going to be plus 2 log of 2 squared. Now using our log laws, we can bring that exponent down the front of the term. So this will be 8 take 2 times 3 is 6 log 2 plus 2 times 2 is 4 log 2. And then we have negative 6 log 2 plus 2 log 2. This is 8 take 2 log 2. And then to get it in the form a log b, we can raise 2 to that power of 2 again. So this will be 8 take log of 4. For a final answer where a equals 8 and b equals 4. That was question 12 for 5 marks. Question 13 gives us this figure, and it says the figure shows a container in the shape of an inverted right circular cone which contains some water. The cone has an internal base diameter of 4 meters and a vertical height of 9 meters. At time t seconds, the height of the water is h meters, the volume of the water is v meters cubed. The water is modeled as leaking from a hole at the bottom of the container at a rate of pi on 324 root h meters cubed per second. Part A says show that while the water is leaking, h to the power of 3 on 2 dh on dt equals negative 1 on 16. Okay, so we're dealing with some differential equations here. Firstly, we have the rate of change of volume with respect to time. So that's dv on dt. Let's write that down. This is root h. We also have the volume based on this formula. So v equals a third pi r squared h. And that's actually all we really have. The other detail, the tricky detail here that I think is the hardest to spot, is we have the ratio of the radius to the height. So the ratio of the radius to the height. The radius is 2, the height is 9, so this ratio is 2 to 9. In other words, the radius equals 2/9 of h. That's a tricky detail to spot. Took me a while to figure that out. The reason we need this is because we want dv on dh, and we need to use this formula to find that. The reason we need dv on dh is because we can use the fact that dv on dh times dh on dt equals dv on dt. This is from your differential equations work. Basically, you can think of this as the dh's cancelling out. So the rate of change of volume with respect to height multiplied by the rate of change of height with respect to time is the same as the rate of change of volume with respect to time. So we have dv on dt. We want dv on dh, and we're going to use this formula with this plugged in for r. If you want to derive this with respect to h, what's going to happen with that r? You're going to just be stuck with that r, and you're not going to be able to get rid of it to get this formula in this form. So we need to plug in 2 on 9h for r, so we get v equal to a third pi times 2 on 9h squared times h. Then this is a third pi times 4 on 81 h cubed. So then this is 4 on 81 times 3, which is 243 h cubed. So then we can get dv on dh by differentiating this. So bring that power down the front and then subtract 1 from the power. So actually we're just going to get back to 81. So we get 4 on 81 h squared for dv on dh. And for some reason I forgot to write the pi there. So it's 4 pi on 81 h squared. So now we have dv on dh, we have dv on dt. Plugging that in here, we can say that 4 pi on 81 h squared times dh on dt equals dv on dt, which is pi on 324 root h. Okay, now we need to simplify some of this. So 324, 81 on 324, let's do that. So 81 on 324 is a quarter. And then we're also going to divide by 4 on this side. The pi's will cancel if we divide by pi. Okay, and so we get h squared dh on dt equal to, what was this? This was a quarter divided by 4, so that's 1/16. And actually, I've also forgotten another small detail here, which is because this water is draining, this rate is actually negative, a negative rate. In other words, the volume is decreasing over time. So we need to introduce a negative to signify that this is a negative rate of change. So this is going to be negative 1/16 root h, and then divide by root h on the left. So this would be h on 2 divided by h to the power of a half. To simplify that, you can think of that as 2 take a half. In other words, h to the power of 3 on 2 dh on dt equals negative 1/16. So there you go. That's how you end up with that equation. Part B says, given that the container was initially full of water, find an equation in terms of h and t to model this situation. Okay, for this, you want to integrate this equation. So I'll write it as this. So h to the power of 3 on 2 dh equals negative 16th dt. So I've brought that dt onto the right hand side. And now if we integrate both terms, we're integrating this in terms of h, we're integrating this side in terms of t. The integral of h to the power of 3 on 2 is, well, we add 1 to the power, so 3 on 2 plus 1 is 5 on 2, and then we divide by that power. So this will be 2 on 5 h to the power of 5 on 2. And then the integral of negative 1/16 with respect to t is just negative t on 16. And then we also need to plus the constant. And this is where this piece of information comes in handy. So given that the container was initially full of water, that means at time t equals 0, h would equal 9, the height of the container. So we can say when t equals 0, h equals 9. So plugging those values in, we get 2/5 times 9 to the power of 5 on 2 equal to 0 plus c. So in other words, just c. So then this is like the square root of 9 to the power of 5. So 3 to the power of 5. And well, let's just go to a calculator for that. So this would be 3 to the power of 5 times 2. And that's not going to divide by 5, is it? Well, we could just get a decimal, I guess. 97.2. So c equals 97.2. So then we have a complete equation. We can say, therefore, 2/5 h to the power of 5 on 2 equals negative t on 16 plus 97.2. And you could get rid of this fraction here if you wanted, multiply by 5, divide by 2, but, you know, there's not really that much point in doing that. Okay, part C says it takes approximately 26 minutes for the container to empty. Use this information to comment on the suitability of this model. Alright, so you can either plug in 26 in seconds, because t is in seconds. Where did it say that? It said it somewhere, I thought. Yeah, at time t seconds. So t is in seconds. You could convert that to seconds and plug it in and get h. Or you could let h equal 0 and find t. That's what I'm going to do. So when h equals 0, we get negative t on 16 plus 97.2 equal to 0. And then solve this for t. So this would be 97.2 multiplied by 16. And the negatives would cancel, so you get a positive time. So t equals 1555.2, and then we want to divide by 60 to get that in minutes. So that's 25.92 minutes. 0.92 minutes. And that's pretty close to 26 minutes, right? We'd say it's approximately 26 minutes. And because it's so close, we can say that the model is suitable. So something like this: the real time and predicted times are close, so the model seems appropriate. And that was question 13 for 11 marks. Question 14 gives us this graph, and it says the figure shows a sketch of the curve C1 with parametric equations x equals 4 root 5 on 5 sine t and y equals 2 sine 2t, where t is between 0 and 2 pi. Part A says show that the Cartesian equation of C1 can be expressed in the form y squared equals kx squared times 16 take 5x squared, where k is a constant to be found. Okay, firstly, let's recognize that we can write y, which is 2 sine 2t, as 2 times 2 sine t cosine t. So this is 4 sine t cosine t. And now if we want y in terms of x, we need to substitute some, expressions for x for sine t and cosine t. Well, we can express sine t in terms of x pretty easily. So because x equals 4 root 5 on 5 sine t, we can rearrange this in terms of sine t. This would be sine t equal to 5x over 4 root 5. So we can substitute that for sine t. So this would be y equal to 4 times 5x over 4 root 5 cosine t. So how do we get cosine t in terms of x? Well, here we can square this equation. So we get sine squared t equal to 25x squared over 16 times 5. And then we use the identity for sine squared, which is 1 take cosine squared t. And this is equal to well, let's cancel those 5s. 25 cancels with 5. This will be 5x squared over 16. And then we can say cosine squared t equals 1 take 5x squared on 16, which we can write as 16 take 5x squared on 16. Okay, so now we need to square this equation to get cosine squared. So y squared will equal, well, firstly, let's cancel those 4's out. So get rid of those. Then this is going to be 25x squared on 5 cosine squared t. So let's just draw a line there. And then we can substitute in this expression for x for cosine squared t. So this will be 25, or actually, let's cancel the 25 and the 5. This will be 5x squared multiplied by 16 take 5x squared on 16. And factorize the 1 on 16th out, so we get 5 on 16 x squared times 16 take 5x squared. And so here we have k equal to 5 on 16. And we're done for part A. Part B says the circle C2 with center at the origin touches C1 at 4 points as shown in the figure. Find the radius of this circle. Okay, firstly, let's recognize that for part B, we can say the equation of the circle is x squared plus y squared equals r squared because the center is at 0, 0. And we also know that y squared equals 5 on 16 x squared multiplied by 16 take 5x squared. Okay, then we can use these two equations to solve for r. So substitute this expression for y squared. We're going to get x squared plus 5 on 16 x squared times 16 take 5x squared equals r squared. And then simplify this a little bit. This will be x squared plus 5x squared take 25x to the power 4 on 16 equals r squared. And then r squared equals 6x squared take 25x to the power 4 on 16. Okay, from here there are two methods you can use to solve for r. So the first one is to use differentiation. So use differentiation to find r max. This is because, you know, you could draw a bunch of circles intersecting with this curve C1, right? But C2 will be where r is at a maximum. And differentiation is really useful when you are looking at maximum and minimum because that's when the derivative is equal to 0. So you can use differentiation. The other method is to use the discriminant equal to 0. This works because this curve C1 is symmetric. So if you look at the positive x coordinates, for example, you will get the same values of x for where the circle and the curve intersect. So the discriminant will equal 0. So I'll go through both. Firstly, I'll use differentiation. Now, because we have r squared, we need to use implicit differentiation. So differentiating this equation for r in terms of x, this will be 2r times dr on dx equal to 6x squared. We'll bring the exponent down the front. This will be 12x, subtract 1, and then do the same thing here. So 4, if you brought that down the front, it would be 4 on 16. So this would be 25 on 4, x cubed. And then, as I was saying, because we're at a maximum for the radius, dr on dx will equal 0. So we can say r max when dr on dx equals 0. So then we can say, well, 12x take 25 on 4 x cubed equals 0. This term over here would be 0. Then we can solve this for x. So factorize x out. So be x times 12 take 25 on 4x squared equals 0. A solution for this is x equal to 0. We don't care about that solution, so let's focus on the other solution, which is 12 take 25 on 4x squared equals 0. And then we get a solution for x squared. Well, this would be 12 times 4 divided by 25. So that's 48 on 25. So then x equals plus or minus the square root of 48 on 25. And then take this value for x and substitute it into this equation to find r. So r squared will equal 6 times 48 on 25. The square root squared is just 48 and 25. And then we've got 25 times the square root of 48 on 25 to the power of 4. Well, that would just be squared, right? So if you raise the square root to the power of 4, you're just squaring those numbers in there. And this is on 16. Okay, then we can just plug that straight into a calculator. Okay, then I get 5.76. I want that as a fraction, which is 144 on 25. Then we can take the square root, so r equals 12 on 5. And I don't care about the negative solution because we're talking about the radius. So r equals 12 on 5 for the answer to B. Then I'll go through the using the discriminant. So taking this equation, I'll multiply 3 by 16. So this would be negative 25x to the power 4 plus 96x squared take 16r squared equal to 0. And then just divide by -1. Okay. And then using the fact that discriminant equals 0, we can solve for r. So b squared take 4ac equals 0. Plugging in b, which is 96, this would be 96 squared, take 4 times 25 times 16r squared equals 0. You can solve this for r. So this would be 96 squared divided by 4 times 25 times 16. And you can see we get the same solution. 144 on 25. So r squared equals 144 on 25. So r equals 12 on 5. So in this question, I would say I prefer this method because it seems like a lot less work, but it's less generalizable. This works because this curve C1 is symmetric, but that might not always be the case, in which case you'd have to use differentiation. Okay, so 2 useful methods there that in this case, as I said, we could use a shortcut, but might not always be that way. Okay, hope you found that video useful. Let me know if you want to see me do more of these, practice exam videos. You can show your appreciation by just leaving a like or a comment, and I'll see you in the next one. Bye for now.